In this lesson, you'll learn how to recognize and extend geometric sequences and find geometric means. How can a geometric sequence be used to describe a bungee jump? A thrill ride is set up with a bungee rope that will stretch when a person jumps from the platform. The ride continues as the person bounces back and forth closer to the stopping place of the rope. Each bounce is only 3/4 as far from the stopping length as the preceding bounce. If the initial drop is 80 feet past the stopping length of the rope, the following table gives the distance of the first 4 bounces. So the first time they drop all 80 feet, then 60, 45, and finally only 33 3/4 feet. The distance of each bounce is found by multiplying the previous term by 3/4. The successive distances of the bounces is an example of a geometric sequence. The number by which each term is multiplied is called the common ratio. A geometric sequence is a sequence in which each term after the non-zero first term is found by multiplying the previous term by a constant called the common ratio, which is represented by the variable r, where r does not equal 0 or 1. So symbolically, the first time they do it, we've got just a, then a times r times r, which is the same as r squared. A times r squared times r cubed. So if we start with 1 and multiply it by 3 times 3 times 3 times 3, and we could keep going forever. Determine whether the sequence is geometric. Well, I can go times 4 times 4 times 4. So yes, it is. The pattern here, I'm adding to each time. So we did this way back in lesson 4-7. This was called an arithmetic sequence. So to answer their question, is it geometric? No, it's not. Find the next 3 terms in the geometric sequence. They told us the sequence is geometric, so to find the common ratio, I can just divide 2 consecutive terms. So if I take negative 28 divided by 20, I'm going to get my common ratio, which is negative 1.4. And so checking it out with a calculator, if I take 20 times negative 1.4, I get negative 28. Times negative 1.4, I get 39.2. When I take 39.2 times negative 1.4, I get my next term, which is 54.88. And so I'm going to take that times negative 1.4 again, and I get 76.832. And multiply again times negative 1.4, and I get negative 107.5648. Definitely a problem designed to be done with the aid of a calculator. Easy if you got one. Okay, once again, they told me it's a geometric sequence, so I can find the common ratio by dividing the second term by the first term. And this one comes out as 3/4, or you could use 0.75. It really doesn't matter. So whichever form you prefer, we're just going to start multiplying. And wouldn't you know, 64 times 3/4 is 48. 48 times 3/4 is 36. And now the question begins. What do I get next? 3/4 of 36 was 27, and now, okay, it's not going to come out even anymore. I get 20 1/4 times 3/4 again, and I get 15.1875. Again, with a calculator, not bad at all. The population of the African country of Liberia was about 2,900,000 in 1999. If the population grows at a rate of about 5% a year, what will the population be in the years 2003, 2004, and 2005? Okay, I cheated and used their typed up version because it's kind of a lot of writing. It's not much work. We're going to start with their initial value, take it times 1.05, because it's growing, it's an exponential growth. And then we're going to take that amount times 1.05 times 1.05, and so on. So a fair amount of writing down from the calculator is all we have. The population of the Baltic state of Latvia, they said, was about 2.5 million in 1998. And they said at that point the population was growing, which it looks like it was at that point, at an annual rate of about 2% per year. Current data, guess what? It is no longer growing, it is now in decline. So I thought this would make an interesting question. I'm going to change up their question. So using current data, in 2013, Latvia's population was 2.013 million, and it is now declining at basically 1% per year. So let's predict into our future here the population for this little country in 2014 and 2015. And they're comparing it to the population of its southern Baltic state border there of Lithuania. Estonia is more prosperous, so I guess they didn't compare them. So very similar to our exponential decay model. To find the next year, we're going to take 1 minus 1, or 0.01 or 1%, and multiply that, and I get a 2014 population predicted at 1.99287 million. So using that same prediction again, they would go down to 1.9729 million in 2015. As with arithmetic sequences, you can name the terms of a geometric sequence using a sub 1, a sub 2, a sub 3, and so on. Then the nth term is represented as a sub n. Each term of a geometric sequence can be represented using r and its previous term. A third way to represent each term is by using r and the first term, a sub 1. So if our sequence was 2, 6, 18, 54, we could write that symbolically, our first term, second term, third term, fourth term, expressing it as r times the previous term, times 3, times 3, times 3. Symbolically, first term times one factor of a common ratio, second term times the common ratio, third term times the common ratio, or most useful, we could do first term times, okay, I have no factors of the common ratio, first term times one factor of the common ratio, first term times two factors of the common ratio, first term times three factors of the common ratio for a sub 4. And that pattern is going to continue forever, where the exponent of your common ratio is always one less than the term you're on. The nth term, a sub n, of a geometric sequence with the first term a sub 1 and a common ratio of r is given by a sub n equals a sub 1 times r to the n minus 1. To find the eighth term, I'm looking for a sub 8 equals, my first term they said was 7, times, they said the common ratio was 3, and then it's going to be to the 8 minus 1, which normally if I were doing this on my own, I would just write to the 7th power. We type it in the calculator, and we get 15,309. If you have any issues typing in the calculator, please ask. Missing terms between two non-consecutive terms in a geometric sequence are called geometric means. In the sequence 124, the geometric mean between 104 is 20. You can use the formula for the nth term of the geometric sequence to find a geometric mean. Find the geometric mean in the sequence 7 something 112. Okay, my first one is a sub 1, my something term is a sub 2, and then I have a sub 3. So in the formula, I know my third term, I know my first term, and we can find the common ratio, and we said this was 3. So my third term is 112, my first term was 7, I don't know the common ratio, but 3 minus 1 is 2. So every time we do a geometric mean, we're going to have a 2 there, because we're always going to have 3 terms. Okay, so to solve for r, I'm going to divide both sides by 7. And happens to be, they gave us a perfect square. When we take the square root of both sides, r could be positive or negative 4, because remember, negative 4 times negative 4 is also 16. So when we substitute back in, we can have 7 times plus or minus 4, so our geometric mean is going to be positive or negative 28. A geometric sequence is a sequence in which each term after the non-zero first term is found by multiplying the previous term by a constant called the common ratio, r, where r does not equal 0 or 1. The nth term, a sub n, of a geometric sequence with the first term a sub 1 and a common ratio of r is given by the formula a sub n equals a sub 1 times r to the n minus 1.